Okay, let's look at something more interesting. Let's look at permutation. Permutation of an object means how many unique lineups can I get. So, for example, imagine that you have 4 friends in your sport team and you are the captain. So now you need to decide in what order your friends will go. For example, running or something like that. So, how many possible lines up do you have? Well, if we try to solve this kind of logically, in first round, you can choose one of your 4 friends, right? So let's write 4. Then in the second round, you are choosing one, but only from 3 remaining friends, because one of them ran in first round, right? So let's write 3. Now, you have only 2 options. Why? Well, one of your friend ran in first round and some other friend runs in second round. So you can pick only one of the 2 remaining friends. So let's write 2. And lastly, you have 1 friend remaining. So let's write 1. Now, I believe you should see that between these numbers will be multiplication. Why? Well, if you pick Bob first, then you have 3 possible options in second round and 2 in third round and so on. It is pretty much the same as with t-shirts and trousers. But now you are picking people and there are more rounds than 2. I hope this makes sense. So now the result will be 4 times 3 times 2 times 1, and that is 24. But some of you might stop in here and see that this is actually factorial of 4, and you are right. If you are one of those people, good for you. But anyway, it is factorial of 4. For those of you who don't know what factorial is, it looks like this. In general, there can be n, and factorial is defined by this exclamation mark. But what it is? In general, factorial of n is n times n minus 1 times n minus 2 and all the way up to 1. So, for example, factorial of 6 will be 6 times 5 times 4 times 3 times 2 times 1. And factorial is also the general result of permutation. So, if you have permutation of n objects, the result will be factorial of n. But I don't want you to use this formula. Why? I want you to think about the problem. When you use a formula and don't think about the problem, it is useless for you. But when you think about it and solve it by logical deduction, you are kind of working out your brain. I know this sounds a bit funny, but it is true. And you can also write it down like I did in the first example. So there is no shame in that. But don't use this formula just because it works. So now let's look at second example. You can try to solve this one by yourself and then go back and check with me. So it goes like this. Imagine that you have 8 books about computer science and then you have 5 books about math. How many possible lines up do you have when you want these 8 books about computer science on left side of table and these 5 books about math on the right side of table? Feel free to pause the video and try to solve it, and don't worry if you get stuck, I will be here to help you out. So let's start by splitting this task into 2. How? Well, we need to line up all the computer science book and we also need to line up all the math books. So one task is to align computer science book and second is to align math books. Let's start with computer science book. There is 8 of them and we need to line them up. So when we are picking first, we have 8 options, right? And then when we are picking second one, we have only 7 options because we already picked one as first. then we have 6 options because we already picked first and second, and we cannot have one book on 2 places, right? And this will go on and on until we get to 1. So the result is factorial of 8. Let's look at the second task, where we want to line up 5 math books. So when we pick first, we have 5 choices. Then we are picking second and we have 4 books. And so on until 1. So we solve the subtask. First one is factorial of 8 and second one is factorial of 5. Now let's think about what to do with these results. And I want to imagine this in the real world. If you somehow line up your computer science book, then you have factorial of 5 options how to line up your math books, right? And then if you change the lineup of your computer science books, you once again have factorial of 5 options how to line up math books. So now you should figure out that for every lineup of your computer science books, you have factorial of 5 options how to align your math books. You also know that there is factorial of 8 of possible lineups of your computer science book. So the result will be factorial of 8 times factorial of 5. And this will be really big number. So yeah, I hope this makes sense. That is kind of how you compute permutation. Remember, in permutation you have n items and you want to know how many lineups there is. Okay? If you have any questions, feel free to ask and I will see you next time.